right, section 1.3 is modeling with linear functions. Recall, when writing an equation of a line, if you are given the slope m and the y-intercept b, use slope-intercept form y is equal to mx plus b. If you are given the slope m and a point, x1, y1, use the point-slope form, which is y minus y1 equals m times x minus x1. And if you're given 2 points, x1, y1, and x2, y2, first use the slope formula. M is equal to y2 minus y1 over x2 minus x1 to find m. Then use the point-slope formula for either given point. So example 1, the graph shows the distance Allison hikes in hours. Write an equation, I had n there, I already crossed out that one because that was a mistake, of the line and interpret the slope. How long does it take Allison to hike 14 miles traveling at the same rate? So on this one here, we can just go ahead and say our slope is equal to our, again, slope is rise over run. And as long as it's going through the origin, we can just use the other point we have. So the other point we have there is 7 and 24.5. So our rise, which is our y direction, is 24.5. Our run, which is our x direction, is 7. And if we work that out, we would find out that it is 3.5. And again, that 3.5, our slope is equal to our m. So up here, it's mx plus b. So on this one here, our y-intercept, if they give us a graph, you can usually see where the y-intercept is. Our y-intercept is right here. So that is our y-intercept, and as you can see, it's 0. So the equation of our line is going to be y, well here, let me put b is equal to 0 for you. Our equation of our line is y is equal to m, which is our 3.5 times x plus b. Well, our b is 0, so I don't really have to write it down. If you put plus 0, that would be okay, but you really don't need to do that. All right? So then it says to interpret the slope. So when we interpret it, that means we're going to talk about it. So the slope indicates that Allison hikes 3.5. Again, our y direction was miles, and our x direction is hours. So she walks 3.5 miles per hour. All right. Then it is saying, how long does it take Allison to hike 14 miles traveling at the same rate? So we know that y is equal to 3.5x. And in this case here, they're telling us that our y is equal to 14. So if our y is equal to 14, how am I going to get x by itself? So you're going to tell me I'm going to divide both sides by 3.5. And that would give us 4, if you worked it out. And 4, well, the x direction is hours. So you should have hours. And there's your final answer for that. There was our answer for our slope. Okay. So example 2, Kelly and Kim are both babysitters. Kelly charges a flat rate of $10 per hour. I mean, $10 plus $6 per hour to babysit. The table shows the total hourly fee that Kim charges to babysit. So who charges more per hour? All right. So first thing we're going to do is we are going to write an equation for both babysitters. All right. So if we look at Kelly, they tell us that no matter what, she's going to charge you $10. She walks to your house, you say, I don't feel well, I'm not going to go out. She's still going to charge you $10. All right. So that's kind of like your y-intercept if you want to think about it. And then she's going to charge you $6 per hour. So she's going to charge you 6x plus 10. All right. For Kim, we are going to use any 2 points from the table. All right. You know, I'm going to be lazy because I always am. So I'm going to use the first two there. I'm going to call the x1s x1 and x2. I'm going to call the y1s y1, y2. All right. So again, first we're going to find the slope m. And again, m is from up above y2 minus y1 over x2 minus x1. So our y2 is 26 minus 22 over our x2 is 2 minus 1. So for this one here, it's going to be 4. All right. So now you're going to use the point slope form to write an equation. All right. So the slope form is going to be again y minus y1 is equal to our slope we just said was 4, and it's going to be times x minus x1. Okay. So if we solve for that, we'll get, well, what is our y1? Is 22. And then we have 4x minus, well, in this case, I had 1. All right, I'm going to keep going. So y minus 22 will stay the same. We are going to distribute that 4 through the parentheses. So I'll have 4x minus 4. And then if you think about it, to get y by itself, you're just going to add 22 to both sides. So I'll end up with y is equal to 4x. Negative 4 plus 22 is a positive 18. All right, so now I have an equation for both babysitters. All right, now on this here, when we're asking who charges more per hour, we're going to look at the slopes. So compare slopes. All right. So when we do that, like I said, compare the slopes, it shows who charges more. All right. So here I'm going to box them for you. So there's one of my slopes. There's my other slope. So who charges more? Kelly charges more. Again, because we were talking about per hour. All right. If you look at it, Kim actually charges more at the beginning. Kelly only charged 10 for stopping at your door. Kim would charge you 18. All right. Then it says, how many hours must Kelly and Kim babysit for their total fees to be the same? So what does it mean to be the same, people? It means they have to be equal. So if we want them to be equal, we're going to take 6x plus 10, which was Kelly. And when they're equal, Kim is 4x plus 18. And now we're going to just solve those. All right, so I'm going to take that 4x and I'm going to move it over to the other side of the equation. So now it becomes negative. So 6x minus 4x is equal to 2x. So 2x plus 10 is equal to 18. I'm going to take that 10, I'm going to move it to the other side of the equal sign. It was positive on the left-hand side. So when I move it over, it's going to be negative. So 18 minus 10 would be 2x is equal to 8. And now I'm going to divide by 2, and I will get that x is equal to 4. And again, you have to put the units. Now, with big ideas, they usually put it there for you, but a lot of times they won't. So make sure if you're taking a test, that's important that you put the units or they will dock you. All right? So last thing we're going to talk about is finding a line of fit and the lines of best fit. So data do not always show an exact linear relationship. When the data in a scatter plot show an approximately linear relationship, you can model the data with a line of fit. The line of best fit is the line that lies as close as possible to all the data points. Sometimes it's going to be perfect, sometimes it's going to be really close. We can use our calculators to do this by using linear regression. So, example 4. The table shows the amount of fruit used to make a smoothie in ounces and the total cost in dollars of the smoothie. Use linear regression on your graphing calculator to find an equation for the line of best fit. Estimate the cost of a smoothie that is made using 8 ounces of fruit. So first we need to get our equation. Again, since it's linear, you know it's going to be y equals mx plus b. All right? So now, I'm going to go ahead and go to my calculator here for you. And over here on the plus sign here, all right, this is using the Desmos. If you're going to use something else, I don't know how to help you. All right? So if I don't know how to help you on those, you might have to Google it. So if we're using this one, which is the one on your Big Ideas calculator, I'm going to add items. So this time we're going to add a table. All right? So now if you go down here on your keyboard, you can see that we can put in stuff. All right. So we're going to plug in 2. And you'll notice that when I press the enter, it's going to make it go down. All right. So I have 2. Then I have 1. I have 4, 7, 10, 3, 6, and 9. And scroll over to the other side and move all the way up and go ahead and do 2.10. Okay. I'm going to do 1.5, 3.05, 4.45, 5.95, 1.75, 4.00, and 5.35. All right. So now, if you're using the one on your calculator, ladies and gentlemen, you should be able to see, once you put it in, you should see this button right here. And if I click that, it'll zoom fit. So it takes all of my points and I can actually see them now. All right. So now what we have to do is we have to go to the second one here. So we're going to click on this one here. And now we're going to go ahead and we're going to say Y. So actually, I think it'd be easier if you went here and you're going to do Y. And when you're using this calculator, you have to do a sub 1. So to do a sub 1, you're going to have this one right here, this A subset B here. So if I plug that one there, I'm going to get a 1 and I'm going to put it there. All right. Now you're going to have to tab, because if you don't, then it's going to put your little tilde right there. So press your arrow button if you want. That's the easiest way to do it. And this here is your tilde. Okay. So then, again, we're going to write M, and then we're going to have to do on big ideas. You have to do on decimals, you have to put in the ones there. So I have the M. I don't put a 1 on that one because it's not one of my variables, but on my X, I'll still have to do the same. And I'm going to do, hit this here again, and I'm going to put a 1. And then notice how I'm having a line right there already. Again, tab it so it comes up, or right arrow it. And then we're going to do plus. And then we're going to say B. Now notice when I did that, ladies and gentlemen, it gave us some numbers. All right. So here, let me get rid of my thing here so you can see the numbers. So it gave us our M is equal to, well, we're talking money, right? So if we're talking money, why don't we just go ahead and round that to the nearest hundredth? So if we did that, our M is going to be 0.51. Our B, if we round that one up, that'll be 0.87. All right, so we're going to write that here in a second. What else to notice on this one here is our R value, not the R squared, but the R. So if we see our R is equal to 0.987. So I want you to think that is pretty close to 1. All right. So you should write that down somewhere because we are going to need all of those here in our next thing. So going back to our paper here. if I go and I write this, okay, again, it's y is equal to mx plus b form. All right, I just told you that our m was equal to 0.51. We have x, and we just saw that our b was 0.87. Okay, and then I told you to write down our r, and I'll show you what that is here in a second. But it's saying, so here is our equation that they wanted us to write. And now they want us to find the cost of a smoothie that is made using 8 ounces of fruit. So our x value would be 8. So we're going to plug in y is equal to 0.51 times 8 plus 87 hundredths. And if you work that out, again, putting it to the nearest hundredth, you would get $4.95. All right? So the last thing I asked you to write down was our R. So if you looked, we had an R of 0.987. So that's called the correlation coefficient, and it is a number from -1 to +1 that measures how well a line fits a set of data points when R is near 1. The point lies close to a line with a positive slope. When R is near -1, the points lie close to a line with negative slope. And when R is near 0, the points don't lie close to any line. So if we look again at what we did here real quick before I finish, if you look, here's our line of best fit. And it does hit pretty much almost all of them. This one right here would be called an outlier. But other than that, it's pretty close to 1. Would you agree? So same thing when you do the homework, you're going to do the same kind of thing, people. So I hope that helped you. Thank you.